A confirmation about the audio, please, guys. If the audio is clear and available, kindly confirm. Thank you. We shall be starting in a couple of moments. Few of the students are still joining us. So, hello, a very warm good morning to all of you, and welcome to Baiju's Exam Prep IES. Welcome to another session of climatology, where today we shall be developing the concepts where we left off yesterday. So, yesterday we have had a discussion about the aspects when we talk about the types of rainfall. That is where we initiated the discussion yesterday. We talked about how is it that we have different kinds of basically rainfall which is observed, not different kinds, but because of different reasons, causative factors. So because the causative factors would be different, hence the type of rainfall would also be differentiated. So for example, you have convectional rain, which is created because of rise of air column and rise of air parcel, thereby leading to condensation happening at a particular height, leading to formation of cumulonimbus cloud types. So that is a convectional rainfall. Similarly, we took a look at what do we understand by orographic rainfall, what do we understand by frontal rainfall. So these are the factors that we looked at yesterday when we initiated. Then we took a look at the types of fog and what do we understand by the concept of air masses, the source regions from which the air masses gain their properties. And then we understood the aspect of the fronts. We understood what are these fronts, where do they exist, the differentiation in terms of the types of fronts which are in existence. So there we saw the stationary front, a cold front, a warm front, as well as the occluded state of the front. So the four different states of the front and also the associated weather pattern in each of these frontal formation is again something that we delved into. Then after that, we initiated the discussion about the types of cyclone. That is a temperate cyclone, its process of formation, the various different stages involved. And then what do we understand by bomb cyclone or explosive cyclogenesis? Tropical cyclones, their process of formation, and the naming of the tropical cyclones as well is something that we focused upon. Then eventually we moved on to understand what do we mean by Walker circulation, where we observed that across the region of the Pacific, because the Pacific is so very vast, so you have differential rates of temperature or differential temperature which is experienced between the eastern and the western Pacific, where we observed that due to the existence of a continuous movement of trade winds in this region, what that meant was that the surface water from the region of the entirety of Pacific, Central Pacific, the surface waters would be carried away. And those surface waters which would be warmer, they would be accumulated in the region of Western Pacific. That is near the Australian and Indonesian coastline. That is where you would have the accumulation of these warm waters. And the accumulation of these warm waters would end up creating here a higher temperature region, which would indicate a low pressure. And meanwhile, as the surface water would be carried away by the trade winds, the subsurface water would be exposed in the region of Eastern Pacific, and that would be the colder water, which would create a high pressure. So at the same latitude, you have the simultaneous existence of a high pressure and a low pressure system. So winds will be in motion between that high pressure to low pressure. And these winds, which would be moving, basically, they would come towards this region of low pressure. They would be rising up. Okay. Here they would form significant amount of convective clouds, bring heavy rainfall in the entirety of the region of Indonesia, Australia, and so on. And the entire circulation would thereby be completed. So this is a circulation which is happening across the same latitude, but across different longitudes. Hence, it is referred to as a longitudinal circulation or an east to west circulation happening in the region of Pacific. And this circulation is what is referred to as a Walker cell or a Walker circulation. Now, due to this Walker circulation being in existence, we observe rainy conditions in the region of Western Pacific, that is the Australian as well as the Indonesian coastline, whereas we observe dry and fair weather conditions in the region of Eastern Pacific, and that is in the region of the Peruvian coastline or the South American coastline. So that is what the Walker circulation is all about. And this Walker circulation, basically, as you can observe, it accumulates warm water region in the area of the western portion of Pacific. Now, this Walker circulation, overall, its impact is not only something which is restricted to the region of the Central Pacific. And basically, here we will start observing from now on that how this Walker circulation will also have its impact across Indian Ocean, also will have its impact across the other portions of the world. So basically, if you take a look at this Walker cell or the circulation pattern created by this Walker cell, you would observe that this is something where you have a low pressure in the region of Western Pacific. And here you have a comparative high pressure which is created. Please understand, it needs to be comparative high and low pressure. It need not be an absolute high or low pressure, right? So even the pressure as compared to the Western Pacific, even if it is slightly greater, it can induce a kind of an airflow or an air movement. Now here you will observe that because there is a low pressure created in the region of the Western Pacific, winds would also be coming over from the region of the Indian Ocean. And these winds would then converge over the region of the Western Pacific. They would rise up and eventually they would diverge. So here you would observe a kind of a sinking air column even in the region of Indian Ocean, right? Southern and Central Indian Ocean, there you have a sinking air column. Okay. Now, wherever you have a sinking air column, in that entire region, you generally observe the creation of a high pressure. And remember what we studied in the portion of cyclones. For a tropical cyclone to exist, or for a tropical cyclone to get created, you do need a pre-existing low pressure system. So only when you have a pre-existing low pressure system will you observe cyclonic formations to be very prominent. In this case of a normal Walker cell, you would observe that in the region of the Western Indian Ocean, there is a high pressure created due to sinking air. So from this also you can basically gather an idea that when the normal conditions exist, when the Walker circulation is in existence, Arabian Sea region is not conducive to create a cyclone or to observe a kind of a cyclone. Okay, so under these conditions, normally you can expect cyclonic circulations to happen in the region of South China Sea, in the region of the Andaman Sea, in the region of Bay of Bengal. Whereas in the region of Arabian Sea, because you have sinking air column, you won't expect the cyclonic formation to happen. Now, these are the things that we and the patterns that we studied yesterday. We also studied about upwelling and downwelling, where we basically had an observation that we made that when you have a large oceanic area or a large water body, Now, surrounded by continental landmass, let's suppose on both the ends. Now, the wind pattern in these areas, the winds, they will end up leading to different types of circumstances and different types of water flow because of their movement. So, as the wind blows here, as the wind is in motion, the wind will carry the top surface water along with it. And when the top surface water is carried away by the wind, the subsurface water in the lower region, that subsurface water emerges and comes up to replace that surface water which has been carried away. Now, this is an upward motion of water, right? From the lower regions to the upper regions to the surface regions, this is an upward movement of water. And hence, this upward movement of water is referred to as upwelling. And we had seen yesterday also that whenever you have the condition of upwelling, in that case, the sea surface temperature here will reduce because the subsurface water is generally cooler. So, reduction in sea surface temperature. Okay. Why? As the subsurface water is cooler. Water is cooled. Okay. Now, this is something that we observed for upwelling. Now, we also observed and we also noticed that generally it is the offshore winds moving from land to sea, which will create that upwelling, something which is happening across Eastern Pacific during the Walker circulation, that is across the South American coastline, is where you will observe this. Now, meanwhile, as these winds move on, these winds will continue to accumulate the warm surface water. And all that warm surface water, eventually, after getting accumulated, would be pushed down in this area because they would have no other place to go. So, here, all that warm water eventually would be pushed down because the winds would be bringing in more water along with them. And that is what we refer to as the downwelling because it involves the downward forced movement of water. So, this is what is downwelling. Generally observed when the winds are onshore. Now, downwelling means that in this area you have so much amount of warm water on the surface that some amount of warm water is deliberately being pushed downside. So that means downwelling is associated with higher sea surface temperature. Higher sea surface temperature. That is what it is associated with. Now, when we talk about this upwelling and downwelling, well, upwelling per se is also beneficial for the marine life in many of the forms. Marine biodiversity, the fish population, and for the fishery sector in economy in general, upwelling is beneficial. Why is it so? Because when we talk about upwelling, there we know that the subsurface water or water from the lower levels, they basically rise up, right? Water from the lower levels, they rise up and they come closer to the surface. Okay. Now, in this situation, water from the lower regions generally have the availability of nutrients. And then when they come closer to the surface, sunlight is also made available to them because at a greater depth, sunlight is not available to the water. But as they come closer to the surface, sunlight is also available to that water. And in the presence of sunlight, in the presence of nutrients, you will observe that the phytoplankton population, phytoplankton is an algae which forms the base of a marine food chain. So the phytoplankton population starts increasing significantly. And when the number of the phytoplanktons that keeps on increasing, that ends up benefiting the zooplanktons as well. And that ends up benefiting the host of various different species in general, because when the phytoplankton population increases, zooplankton, their population also increases because they get the availability of food, and then both of them help in improving the population of the fishes because of tremendous amount of availability of food in that area. So that is why upwelling is always beneficial for the fisheries and the fishing sector. Upwelling is beneficial for the fisheries sector. Okay, that is where upwelling is significantly beneficial, where the fisheries sector basically benefits. A lot of farmers, they get a lot of fish catch. So that is why, for example, in the western coast of South America, even in the western coast of North America, during the phase of upwelling, the seawater slightly turns greenish because of abundance of population of phytoplanktons, because phytoplanktons are green algae. They carry out photosynthesis, so they enrich the water with oxygen as well, and their population, when it starts blooming, that is when the zooplanktons and other fishes, they will benefit. So that is what was upwelling and downwelling. Here is the written definition about it. So when we talk about upwelling, so winds blowing across the ocean surface, they tend to push the water away. Water then rises up from beneath the surface to replace the water that was indeed pushed away. This process is known as upwelling, and it occurs in the open oceans and across coastlines. Right? So in reverse process, what we refer to as downwelling, that also occurs when basically wind carries the surface water to build up along a coastline, and the surface water eventually sinks downwards. So that downward motion of water, the sea water or the oceanic water, that is downwelling. That is also caused by the wind. Upwelling, that is what I told Suresh. Okay. Upwelling is when you have the winds carrying away the surface water. Now, in that condition, see, whenever you have, let's suppose here, the existence of a wind which moves like this. Now, it will carry the top surface warm water along with it. That means when the top surface water, which is the warmer one, which is carried away, then the bottom subsurface water rises up to replace it. And when that is replaced, that process of upward motion of subsurface water, that is upwelling, right? Upward motion, upwelling, downwelling, downward motion. So when the wind carries the surface water, subsurface water rises up. When the wind pushes or accumulates too much of warm water in a region, then that water is pushed down deliberately. So that is downwelling. Okay. Now, upwelling and downwelling we had covered yesterday also. Anybody having any doubt in upwelling and downwelling? We had covered that in significant detail yesterday as well. Any doubts that you have in the portion of upwelling and downwelling? No. Good. So now we come to the ENSO cycles, that is El Nino, Southern Oscillations. We'll try to understand what they are and what is this oscillation about. So basically, when we talk about the region of Southern Central Pacific or Equatorial Pacific and slightly to the south of it, now there, generally during the summer season of Southern Hemisphere, that is during the months of November, December, January, February, and mostly in those times, you have conditions where the Pacific ends up indicating a slightly higher than average temperature, a slightly lower than average temperature, or a normal temperature. In all these three different conditions, you have different type of atmospheric circulation which is initiated across the Pacific, which has got the potential to alter the climate not only in the region of the Pacific but across the entirety of the world. Now, because the conditions will move from either the warming of the Pacific, the cooling of the Pacific, or somewhere in between the normal conditions, these conditions are the ones which keep on repeating themselves. in the span of every 5 to 7 years, you will have the warming phase, then maybe next year you will have the cooling phase, then meanwhile maybe you have a normal phase. So that is why, because the conditions, they move on or oscillate between these three parameters, hence it is referred to as oscillation. And why southern? Because this entire event takes place immediately to the south of equator. So particularly in the southern hemisphere, that is what is involved here. Hence, southern oscillation. Why El Nino? So El Nino, basically, the genesis of it, the term itself, is one of the most and often repeated anecdotal stories that you would have heard multiple number of times. So basically, it was across the coastline of Peru. Now you have seen that under normal circumstances, that is the Walker cell, the Peruvian coastline experiences dry conditions, fair weather. Why? Because there is high pressure, isn't it? Now, high pressure means no rainfall in that region. And that too in the month of November, December, January, February. Peru will experience a summer season because Peruvian coastline to some extent is in southern hemisphere. So Peru will experience during those months a summer season. Now, when you have the summer and you have lack of rainfall, obviously conditions are not very conducive. It becomes oppressive, it becomes very hot, intolerable, and so on. Now, as the story goes, in one late December time, at the time of late December, that is during the time of Christmas, few fishermen ventured out from the Peruvian coastline and they experienced occurrence of significant amount of rainfall. Now, this was a surprise because generally Peruvian coastline would experience high pressure and a complete lack of rainfall during those summers. But then they experienced occurrence of heavy amount of rainfall. Now, because it was happening in the month of December, they thought about it as a gift from Christ himself. And that is where they named this phenomena as El Nino, or the Christ child, right? Or the boy child, as it is having many different connotations. So El Nino was named as thought to be a gift from Christ. So whenever they had or they would observe the condition that the Peruvian coastline would receive heavy amount of rainfall in this particular summer or the next particular summer or the summer after that, they would name the condition as El Nino, that this time El Nino conditions are there. So Peru, we will receive rainfall, maybe floods as well because of excessive amount of rainfall. Slowly and steadily, the climatologists across the world, they came to be aware of this particular phenomena. Now, so they named this phenomena as El Nino Southern Oscillation, thinking that this El Nino event doesn't occur every year. So you have many years where you have normal rainfall or normal conditions, that is very dry. And then you have years when Peru would receive heavy amount of rainfall. So the climatologists of the world, they were pretty much convinced that in the region of Peru, something happens in the Central Pacific where the Pacific Ocean causes heavy rainfall in Peru in certain years and then drier conditions in Peru for the next years. So they thought the weather condition to be oscillating between El Nino and normal conditions. Later on, when more researches were carried out, they found out that there is another condition which does exist in the Pacific. And that is when Peru becomes much more drier, experiences much higher pressure, and much clearer skies as compared to even the normal conditions. And they named it the opposite of El Nino. So in El Nino, you would have heavy rainfall in Peru, and then the opposite condition of it would lead to excessive dry and drought like conditions in Peru. So the opposite condition of it was what was named as La Nina, which meant the girl child, right? So, like that, now you had three different phases in the Pacific. One in which Peru would receive heavy rainfall, El Nino. One, the opposite of it, when Peru would be extremely dry, drought like conditions, La Nina. And one in between, that is where you have normal conditions of high pressure in Peru. So these three conditions were found out to be existent. These three conditions were found out to be present. And that is where you would observe. Now, from that time onwards, okay, is the audio and the video clear? It is? Good. So for those who are saying that the video is not appearing, kindly refresh. So basically, since that time onwards, people and climatologists have largely confided to this ideal that you have a condition of El Nino, you have a condition of La Nina, and you have a condition somewhere in between. The impact that these conditions will have, or that they do have, that is still something which is being understood to a larger degree. There are still many of the unknowns in that. That a large ocean like Pacific, how is it that we can predict these conditions of El Nino, La Nina, maybe an year ahead, maybe a couple of years ahead, because the Pacific warms up. And when the Pacific warms up, that induces an atmospheric circulation. But all these factors of warming of Pacific, cooling of Pacific, these were understood much later on, right? The factor of El Nino was something which was thought about and understood much earlier. And at that point of time, when El Nino was thought about and when El Nino was understood, nobody had an idea about the implications that this El Nino will have, maybe on Australia, maybe on Indonesia, North America, or India. And that is something that we try to understand with more researches happening. We do know that they do impact definitely our own monsoonal rainfall. So, for the past couple of decades or so, El Nino and the news of El Nino and La Nina, they have started hitting the global headlines because many nations in South Asia and countries such as India, for example, our entire agrarian economy, which still manages to employ more than 50% of our population directly or indirectly, that agrarian economy significantly is impacted by either the conditions of El Nino or the conditions of La Nina. El Nino will always lead to reduced rainfall in India. La Nina will always lead to increased rainfall in India. And that is where the global researchers are now working significantly in order to find out why does that happen in many of the cases, and what are the other implications. Are there these implications observed even in the region of the poles? The recent findings have indicated that even in the polar areas, the movement of wind pattern is impacted by what happens in central southern Pacific. So that tells you how big this particular phenomena is, the impact of it across the various portions of the globe. So we will be talking about all these three phases of the oscillation. When we talk about the three phases of oscillation, here basically you have El Nino, you have La Nina, and then you have the neutral phase. Okay, so the conditions, they would basically oscillate from here to in between to the normal conditions or here. That is what the conditions would vary from. Right? So that is why, as the conditions would vary from either one to the other, that is why it is named as oscillation. And when it was being named, at that point of time, La Nina was not there, not understood at all. So hence, only El Nino Southern Oscillation. So let us try to understand what is this El Nino? When does this occur? What is the impact of it? What are the neutral conditions? And what are the La Nina conditions? Okay, we'll start with the neutral condition. Now, when we talk about neutral conditions, Okay, I have a couple of doubts. El Nino means, that is what I just told. Suresh, are you having a kind of an audio lag or something? Because it appears that as soon as I explain something, I get the immediate, what is it that you said? Or is it something that you are listening on mute? Justin, when the El Nino, it was discovered almost a century back. The event of El Nino, it was not fully understood, but then it was understood. It was something which was discovered almost a century back. Neutral is in which area? Shweta, all these three are in the area of Pacific itself. You have different types of circulations induced in each one of them. What do you want me to repeat, Akshay? The entire thing? The entire thing that we have talked about, you want me to repeat the entire thing? Is it the case? I hope not. We will come to it all, that when neutral conditions exist, which coast will get more rainfall, which coast gets less rainfall, etc. Okay, fair enough. Please point these areas. My dear friends, please have patience. It is not as if this is the last thing that you are hearing about El Nino. We will study much more about what is El Nino, how that El Nino is caused, what is La Nina, where is it that you receive rainfall in El Nino, where is it that you receive rainfall in La Nina, where is it that you receive rainfall in neutral conditions. Neutral conditions mean what? Where is the pressure difference? Everything we will explain. This is just the introductory slide for that. Okay, before you start losing all your patience, and before you start talking about that, no, tell us about the map, what is the kind of question which is, have some patience, my dear friends. I'm still figuring out how many of you are asking me to repeat the entire thing. Sign of congruence on n, that is basically the pronunciation. It is not El Nino, it is El Nino. The pronunciation of it goes like El Nino. So that is why you have that congruation on that. Okay, fair enough. Now listen to this carefully. Wake yourself up and listen to this very, very carefully. I'm not going to repeat it again. In case you still are unable to follow this, you can take a look at the recordings which are available. When we talk about the conditions of El Nino, basically, here you have to correlate it with what we studied in the Walker cell yesterday. So, how many of you have an idea about the Walker circulation that we studied yesterday? And how many of you don't have an idea? Suresh, please let me know. When you have a normal Walker circulation out of Australia and Peru, which receives rainfall? Is it Australia which will receive rainfall, or Peruvian coastline which will receive rainfall during the normal Walker cell? Please let me know. No idea? Okay, beautiful. So that means yesterday you did not attend the session, and straightforward you jump to today's session. And see, that is what I always humbly tell you. This is not the subject like your history or your polity that I jump in the second session. Anyways, Lord Curzon, what he has said, that if I have missed out, I will anyways be able to follow non-cooperation movement. Or if I have missed out the governor, at least I would understand what the president is about and the election of president is about. This is not like that subject. Because if I start going back to Walker circulation now, then I will have to go back to the rise and fall of air parcel there as well. So let's not indulge in that particular aspect. So basically, for those of you who had attended the session yesterday and those of you who did not, try to follow it up. When we have a normal Walker circulation is a normal atmospheric pattern or a circulation in the region of equatorial and central Pacific. Now, in the Walker circulation, we have seen that the Peruvian coastline is very dry. Why? Because there is a high pressure. So, as we have said today also, here, basically, the Peruvian coastline under normal conditions will be dry because you have a high pressure condition due to the sinking air column. And that high pressure condition means lack of cloud formation, means lack of rainfall. Whereas when we talk about the region across the western part of Pacific, that is the region which is going to receive rainfall significantly, convectional rainfall, because of the rise of air parcel, because of the low pressure created. Why is the low pressure and high pressure created? Because of the factors of the wind. The wind basically carries the surface water which is warmer, accumulates it to the western Pacific, and the subsurface colder water gets exposed in the region of eastern Pacific in the form of what is referred to as upwelling. So that is why you have the high pressure in the region of eastern Pacific and low pressure in the region of western Pacific, which induces a circulation at the same latitude. That means under normal circumstances, this is the weather pattern in existence across two ends of the Pacific, where the eastern part of the Pacific Ocean receives significantly drier conditions, whereas the western part of Pacific Ocean, that is the Australian coastline, receives heavy rainfall. Now, because this is an event happening slightly in the southern hemisphere, this is an event which peaks, the heating and the cooling of it peaks during the southern summers. And when is it that we experience southern summers? We experience southern summers generally in the month of November, December, January, February. That is when we experience summer in the southern hemisphere. Now, in the month of December, that means that the Peruvian coastline is going to be very dry, whereas the Australian coastline is going to receive substantial amount of rainfall. But Peruvian coastline is going to be very, very dry. Now, as the anecdotal story goes, basically, one fine December morning, you had few of the Peruvian fishermen going across the coastline, and they experienced the surprising existence of rainfall or occurrence of rainfall across the Peruvian coastline. Now, please understand, when you have otherwise dry conditions during the summer season, it becomes very oppressive. So, when you have the sudden occurrence of rainfall, that is always taken as a welcome gift, a welcome sign, as a good gift, in the sense that now you will get some respite and relief from the very harsh summer. So that is why those Peruvian fishermen, they named that particular gift as the Christ child, right? Or El Nino. So the name El Nino is derived from that because it happened in the month of December, around the time of Christmas. So they thought about it as a gift from Christ himself. And that is why these conditions, when the Peruvian coastline would receive rainfall, that was named as El Nino. Now, people basically were having a kind of an understanding about it that in certain years during the summer, Peru would receive rainfall. In other years, Peru would be dry. So the climatologists, they also heard about it, they also knew about it. So they started calling it El Nino Southern Oscillation. Oscillation in the sense that Peruvian coastline would be dry in certain cases it would receive rainfall. So there would be something happening across the Pacific where the Peruvian coastline would be dry, and then the Peruvian coastline would receive rainfall in the coming days or in the next year or maybe the year after that. So hence it was named El Nino Southern Oscillation. Later on, when more number of research and higher amount of research was carried out, it was basically found out that there is another condition which exists in the Pacific, which is the exact opposite of El Nino. In El Nino, we have heavy rainfall in Peru. The exact opposite would be extremely dry conditions in Peru, much more drier than even the normal Walker circulation. So they named it the opposite, that is La Nina, or the girl child. And now we know that you have three different phases. You have the El Nino, you have the neutral phase, and you have the La Nina. And the climatic conditions, or basically the conditions in the Pacific, they end up moving between El Nino, La Nina, or neutral in the different years. So this entire process tends to repeat itself every 5 to 7 years. Hence, this El Nino Southern Oscillation has become one of the important pointers in terms of impacting the global climate. So what we are going to study now is, what is this neutral circulation? What is this La Nina circulation? When this occur? What is the El Nino condition? Any doubt that you have till now? These three conditions on only on Pacific? Yes. Ankit, because Walker circulation, then the Arabian Sea will experience a high pressure? Yes, that is true. Okay. Suresh, is that understood, my dear friend? I don't want a question to come after we have initiated the discussion for the next topic and a simple one-liner question that repeat and a question mark. I will not entertain such questions. So please do let me know if you have doubts now. Okay, fair enough. So here we will study what these different conditions are. First of all, we'll be starting with the neutral conditions. So when we talk about neutral conditions, this is nothing but the existence of a normal Walker cell that we have studied. So whenever you have the conditions of a normal Walker cell, that is what is referred to as a neutral condition. Neutral condition means what exists under the general circumstances. Under normal situations, what is the condition which is in existence? That is your neutral condition. So when we talk about neutral conditions, this is the condition prevalent in normal situations. Okay, and that basically means Walker circulation. So the normal Walker circulation is basically the neutral condition in simple terms. So what happens in these? We have already studied yesterday. So trade winds, they help accumulate warmer waters in the western equatorial Pacific Ocean, while colder waters, they emerge in the eastern equatorial Pacific Ocean due to upwelling. Now, these cause rainfall in the region of northern Australia, while due to high pressure, there is a lack of rainfall across the western coast of South America. So, Australia receives rainfall under these conditions. Australia receives rains, and basically South American coastline is dry. Okay, so that is something that you observe in the normal conditions. So here you have this as the normal Walker circulation, something that we have studied yesterday as well. Today in the initial part of the class also we have taken a look at it, that all the warm waters get accumulated in the region of the Western Pacific. So average amount of rainfall is observed in the region of Australia, in the region of Indonesia. You have an average amount of rainfall which is received. And here you have an upwelling across the eastern part of Pacific. So here you have a high pressure condition, and that means there is going to be a kind of a dry condition, lack of rainfall across this area. Now, sometimes what happens is that this intensifies. Intensifies how? And what do I mean when I say the term intensifies? So understand this. When you have this kind of a circulation in existence, you have the presence of a low pressure and a high pressure. Low pressure where? In the western part of Pacific. High pressure where? In the eastern part of Pacific. Okay, that is something which is observed. Now in this case, here you have the low pressure and here you have the high pressure. a pressure gradient force is in existence. Pressure gradient force means winds will start blowing. Now, the winds which start blowing, which get accelerated due to this pressure gradient, means what? Means these winds will have the capability to carry more surface water, because as the winds they blow from the high to low, they will have some speed which will be higher than the otherwise trade winds in general. So as they start blowing, they would carry more amount of surface water along with them, and surface water is warmer. So that means after this pressure gradient has been established, the wind patterns they become stronger, and they will lead to a lot of accumulation of warm water in the region of Western Pacific. So the Western Pacific area has got much more regions of warmer water. Over a period of time, the amount of warm water accumulated in the region of Western Pacific, that keeps on increasing as the winds bring in more amount of warm water. Now, all the meanwhile that the winds are bringing more amount of warm water means what? There is greater amount of upwelling happening in this entire region, in this entire territory. You will have more upwelling, means more colder water will be exposed in the entirety of the area. What does that mean? Low pressure has also gotten stronger because more warm water. High pressure will also get stronger because of much more cold water. So can we say that the conditions of normalcy has been intensified? The low pressure has become stronger. The high pressure has also become stronger. So the wind movement will speed up furthermore. As the wind movement speeds up furthermore, what happens? It will carry more surface warm water, more upwelling in the Eastern Pacific, more downwelling in the Western Pacific, and it will keep on increasing. And that condition sometimes leads to a situation what we refer to as La Nina. So when you talk about La Nina here, observe as compared to the earlier condition. If I were to remove all these images, observe here. Earlier, look at the extent of the warm water under normal conditions, and look at the extent of warm water in the case of La Nina. The region of warm water basically has increased. The areal spread of warm water has increased. The areal spread of cold water, observe the areal spread of cold water due to upwelling. This entire region basically has cold water. So, in a way, the winds get stronger, the low pressure gets more intensified, high pressure gets stronger. So, what will be the weather pattern experienced across the Pacific? Australian coastline will receive very, very heavy rainfall. So much so, it can lead to existence and occurrence of floods in the region of northern Australia. Northern Australia during these conditions will also experience occurrence of many of the tropical cyclones. And sometimes even this region of South China Sea will experience the occurrence of typhoons due to this. Now, these events also mean that the Peruvian coastline, which has got much more intense high pressure, that will be much drier as compared to before. So the Peruvian coastline becomes absolutely more dry, drought-like conditions. So that is the situation that you observe in La Nina. So La Nina can be thought to be a much more intensified Walker circulation, where the circulation pattern is the same, but the circulation pattern is strengthened. Okay? So here, when we talk about La Nina, you will observe that the warmer water regions, they have expanded significantly. The warmer water regions have expanded, and so will the cold water areas as well. So La Nina condition is an intensified Walker circulation. That means low pressure across Western Pacific is much more stronger, high pressure across Eastern Pacific is intense. Now, these are the conditions where a significant low pressure develops across the region of the Western Pacific, whereas an intensified high pressure develops across the Eastern Equatorial Pacific Ocean. In a way, it is an intensified Walker circulation. Now, it leads to flood like conditions across northern Australia, while leading to drought like conditions across the western part of South America. Okay, so that is what it leads to. Now, that is the condition of La Nina. Okay, so here when we talk about La Nina conditions, this basically, if you observe the extent of the colder water. That is significantly larger, isn't it? For a significant portion in Central Pacific, you have the presence of that cold water. So that is also what is referred to as the cooling phase of the Pacific, where in the Central Pacific, the average temperature is lower than normal. So that is basically the cooling phase of Pacific. La Nina is the cooling phase of the Pacific. Of Pacific Ocean. That is something that you observe in the case of La Nina. Okay. Now, here here, if you take a look at the schematic cross-sectional image, this also represents, now compare it with the image that we saw yesterday about the Walker circulation. So here you will observe that all the warm water has been, or the warm surface water overall, has been carried away by the trade winds, and all that warm water is accumulated in the region of Western Pacific. Whereas in the Eastern Pacific, you have the cold subsurface water which has emerged. So this area has become very, very cold in comparison to the earlier situation. So that means very heavy rainfall across Australia, Indonesia, Philippines, and absolutely dry conditions in the region of Peruvian coastline due to the high pressure created. This is your high pressure. Is this portion understood? Or do we have any doubts in that? Why there is warm water? The warm water here refers to basically when we talk about an ocean. So when we talk about an oceanic area, so basically, what is the source of heat for the ocean? The source of heat for the ocean is the sun. So it is the solar insolation which heats the water. So obviously, the top surface will be the warmest. And here you will have comparatively cooler waters in the subsurface. Now, when the wind blows like this over this region, it will carry the top surface water along with that. Now, wherever the wind will be blowing, it will be accumulating the top surface water, which is warmer along with that. So eventually, that warm water which you see is basically nothing but an accumulated form of the surface water. Okay. How much time does it take, does air take to reach from Peru to Australia? So there's a regular movement of air. It is not as if you can identify this particular. So think about it. It is not the case that the air which has been in motion from Peru, that air particle will reach up till Australian coastline. You have trade winds. These are the trade winds. All these trade winds are getting supplied from the region of the subtropical high pressure belt. So it is not only from one pocket that it is getting, but in general, you can think about it. It can take few months or multiple weeks in general for the air to reach and cross the entirety of the Pacific. Okay. Now, here, this La Nina condition will have its impact in terms of the atmospheric circulation across the entirety of the globe as well. So here, when you take a look at the La Nina conditions, observe that this circulation pattern will have its impact across the rest of the portions of central and equatorial regions as well. So for example, here observe this is the region of the low pressure, what we are talking about in La Nina. This is, look how extent or how extensive that warm or cold water has become because of upwelling. So the cold water is significantly extending in the region of equatorial Pacific. That is why La Nina is also referred to as the phase of cooling of the Pacific Ocean. Now, in the meanwhile, observe what is happening in the Indian Ocean. In the Indian Ocean, you have a sinking air column in the region of the Western Indian Ocean, which means what? In the region around Western Arabian Sea, you will have a high pressure in existence. In the region around Central Indian Ocean, you will have a high pressure which is in existence. Now, will that high pressure be conducive for the occurrence of tropical cyclone? Absolutely not. That is why even under the La Nina conditions, we had seen under the normal conditions of Walker cell also that it is not conducive in those conditions for the Arabian Sea to experience development of cyclones. So in La Nina condition also, chances are that the cyclone would ideally develop in this area, South China Sea, Andaman Sea, which might morph into a cyclone into Bay of Bengal. But Arabian Sea has got little chance of forming a cyclone in the conditions of La Nina. By the way, these conditions of La Nina that we are talking about, this will be peaking in the southern summers. That is in the month of November, December, January, February. That is when they will hit their peak, right? Because it is in the southern summers where that heating and cooling will be exaggerated in the area, right? We are talking about the equatorial Pacific and slightly to the south of equatorial Pacific. Okay, is that clear? Good. Now, after this, let us try to expand this concept. So till now, we have formed an interrelation between Walker cell, neutral conditions, La Nina, and all of them, where is it that they will have a probability of having a cyclone in terms of northern Indian Ocean? So we have seen that under both the conditions, it is much more likely that a kind of cyclonic development will be observed in Bay of Bengal rather than the Arabian Sea. Okay. So you mean that positive IOD today is also responsible for Arabian disturbance? Well, I did not mean that in any of the things that I have said, but yes, your assumption is correct, or what you are saying is correct. That we come to IOD immediately after that, and we'll talk about it in detail. Okay. Now, here, let us try to understand what exactly happens during El Nino. After all, I'm sure that is something that you would be interested to know about. Had this been a La Nina year, candidates always are interested. Leave everything. Don't tell us about humidity precipitation. Tell me what is La Nina and tell me how it will impact the rainfall. That is what I'm reading in the news headlines. Rest, all the things I don't want to fit it in my mind. Yesterday also I experienced the same thing where everybody was concerned. Tell me about Cyclone Tej. I don't want to listen to anything else. Somehow ensure that Cyclone Tej is drilled into my memory, and temperate cyclone, formation of tropical cyclone, not at all concerned about it. So I understand because it is an El Nino year. All of you are interested in El Nino. So you have to understand why this happens. Okay. The genesis of El Nino begins from a normal condition or a neutral condition, or normal condition or a condition of La Nina. So before that, I want you to take a look further into this image once again. When you take a look into this image, you will observe that there is a kind of warm water accumulation across the Western Pacific, which has gained some amount of height. So the height in the region of Western Pacific, the height of water in the region of Western Pacific is roughly 8 to 10 centimeters higher as compared to the water in the Eastern and Central Pacific. I will reiterate, I will repeat. Due to accumulation of this warm water, and warm water is accumulated by whom? By the winds, the trade wind systems. So the accumulation of warm water means that the western part of the Pacific Ocean gains a comparative height advantage by 8 to 10 centimeters, which might not seem to be very significant to you when you think about 8 to 10 centimeters, but it is huge in terms of the water level from one area to another in the same ocean. Now, that height accumulation in the region of the Pacific, that is sometimes also responsible for creation of the El Nino situation. But before that, let us talk about the basic principles involved. When we talk about here, let's suppose a normal example. You keep a bucket. You keep a bucket of water. Okay. Now do one thing. On one side, or fill it to the brim first. Fill it with water to the brim. Now on one side of it, install a fan. Okay. Install a fan which is moving significantly, blowing air in this direction. Now, as the fan is continuously blowing that air, would you experience water to start accumulating at the other end because of the movement of air? Maybe sometimes some amount of droplets might even spill over. Something that you can understand, something that you can relate to. Water will gain a kind of a height advantage being pushed by the wind, and maybe that water will get spilled over, isn't it? Now let's suppose you switch off this fan. By some reason or the other, you switch off this fan. Now what will happen to the water? Will the water continue to stay in a similar manner, staggered manner? Will the water continue to spill over? No. The water will actually try to flow back, try to gain its normal condition, right? That is something which happens. Now, implementing something similar across the region of the central and equatorial Pacific, all this accumulated warm water is being supported by this wind that we saw in the case of the fan. Something very similar at mechanism is at play to uphold that accumulated warm water. And what is that wind? It is a trade wind. So in a way, the trade wind is supporting that accumulated water in the Western Pacific. But what if the trade winds, they go weaker or they disappear? They become absent for a few days or a few months. What happens? In that situation, the water will flow back. Now, water, when it starts flowing back from the region of Western Pacific, till where will it flow back to? Depends upon the amount of accumulation. If the amount of accumulated water is very significant, it might flow all the way back to the Eastern Pacific. If it is not so significant, maybe up till Central Pacific, but it will indeed flow back. But then there might be another question in your mind, other than the questions that please repeat it. There might be another kind of question in your mind. That is, why is it that the trade winds will weaken? Can the trade winds weaken at all? The answer is yes. The trade winds can weaken. And why is that? So listen to this carefully. And before that, I want you to relate to your natural surroundings also. This year, you had summer season and rainy season. Till now, winter season is coming over. Last year also, you would have, in your collective memory, you would have had a recall of at least 10 such summer and rainy seasons in your recall memory. Now, Have all those summer seasons been of equal temperature on equal date? Or is it the case that sometimes or in certain years, the summer gets much more hotter as compared to the earlier one? The rainfall becomes much less or much high as compared to the previous ones. So what do you think? Is the temperature consistent throughout the summer, or is it something which is variable? What do you think? It varies, right? It is a very simple thing to understand that it varies. Now, if you apply your logic there, that every year the sun shines in the same manner, so the temperature should be the same, but it varies. Why? Because there are a lot of other conditions at play: wind pattern, wind movement, rainfall in certain area, other factors at play which can influence the temperature in your area. Maybe last year the month of May did not have that much amount of rainfall as this year. So this year you had more rainfall in May, so May was comparatively colder, where last year May was much hotter. So what I am getting at here is basically that in the same area, year after year, you can experience different rates of heating. Sometimes the rate of heating can be very high. Sometimes the rate of heating can be lower. Now let us use this to understand the concept of why the trade winds will get weaker, if at all. So where is it that the trade winds blow? Trade winds blow from the region of the subtropical high pressure to the region of the ITCZ. So let's assume this is your subtropical high pressure. This is your subtropical high pressure. Basically, this is where the trade winds are in existence. Okay. Now, what if this subtropical high pressure in itself weakens up? Because it is lying in the region of the tropics, and it is a dynamically induced pressure, if you remember. So dynamically induced pressure means here, if this is the region of 30 degrees, on an assumption, let's assume 30° north, here the air is sinking from above. That is creating the high pressure on the ground surface. But let's suppose once every 3 years or 4 years, as we have experienced in this year 2023, after almost 4 years, let's suppose this time the Pacific receives significantly greater amount of heat. In comparison, the temperature is higher. Just like in your own locality, every year the temperature is different. Certain years, the temperature increases very significantly. So let's assume that this particular year, the region of Pacific is experiencing very high temperature. Now, when the region of Pacific, especially around 30 degrees, very much closer to the tropics, high temperature means what? Water will get warmer and warmer. When the water keeps on getting warmer, that means the air above it will also get warmer. And the air will have a tendency, when it warms up, air will have a tendency to rise, isn't it? So let's assume that here, the air parcel has got heated up and has got a tendency to rise. You already have a sinking air column in that region. And meanwhile, from the water body or from the surface, the air is trying to rise up. What will be the impact on the high pressure? Will the high pressure which is normally existent there, will it increase will it become much more high pressure? Will it remain the same as earlier? Or will the intensity of high pressure reduce? What do you think? Satish, Pranay, Satyanarayan, Abhishek, Niranjan, Shilpa, Priya. Correct. So basically, because you observe that the air is trying to rise up, and that means on the surface, the high pressure will reduce. Let me repeat it once again. For all of you, try to listen to it again. So when we talk about the trade winds are generated from the subtropical high pressure, isn't it? They are generated from the subtropical high pressure and they move towards the region of the ITCZ. But then when we talk about this subtropical high pressure, which is generally in existence around 30° north and south of equator, now sometimes it can also happen that Pacific gets very heated up. The region of the tropics in Pacific in particular gets very, very heated up. Now, when the Pacific gets heated up at around 30 degrees, and that means the air above the region of the water, that will have a tendency to rise up, isn't it? So, above the water, you have air which is trying to rise up, and you have sinking air column from above. So, earlier that sinking air column would be exerting that high pressure. But now you have the air which is trying to rise up in that phase and the midst of it. So what will happen to that high pressure? The high pressure, the intensity of high pressure will reduce. The high pressure will become weaker. So here, due to heating of Pacific, air tries to rise up. As the air tries to rise up, high pressure weakens. In certain cases, the conditionality of high pressure can disappear as well if the Pacific gets significantly heated up. So when that high pressure is very weak or is almost absent, what can you say about the fate of these trade winds? Will these trade winds be in existence? Will they be stronger? No, they will get weaker because the trade winds, their intensity is straightforward dependent upon the amount of high pressure. High pressure, if it is stronger, wind velocity is always stronger. If the high pressure in itself is very weak or almost negligible, the trade winds will become weaker or will become absent. So that means you have a situation when the Pacific gets extraordinarily heated up that the trade winds are almost absent. Now, remember, it is these trade winds which were holding up the warm water, holding up the accumulated water on one end. So if the trade winds will disappear, what will happen to that accumulated water? It will immediately flow back. It will immediately start to flow back. And that leads to a condition of El Nino. Is that understood? I will show with the image, with the map, again I will show it. But are you able to understand or grasp the entire mechanism of it? This mechanism you will not come across in the various reference books. They will straightforward tell you that heating of the Pacific leads to El Nino. It is the actual mechanism behind it, that why this happens. So, and let me assure you, UPSC is not going to ask you the question in detail about it, that explain with the help of the bucket example why El Nino happens. This is just for your understanding. But if you understand this process, you will never forget why is it that El Nino happens. Is that understood? Good. Okay. So that is what leads to the condition of El Nino. So we'll come to it again. Before that, we have seen the conditions of La Nina. We have seen that under conditions of La Nina, Arabian Sea is not conducive basically to create cyclones or to experience cyclones. However, in India, La Nina is associated with higher than average rainfall. Associated with higher than average rainfall. Okay. So in La Nina, higher than average rainfall in India. Why does that happen, or how is it that La Nina leads to higher than average rainfall in India? We'll cover it in the next module immediately after this, while we are talking about Indian monsoon and Indian climate. So you will get a much clearer picture. But till that point of time, do hold your horses. Okay. So let me tell you once again about this portion of El Nino. What actually happens during an El Nino? So basically, When we talk about the condition of El Nino, here. Now, here you will observe that warmer waters, they are accumulated under Walker cell, under the normal Walker circulation. Where is the warmer water accumulated? Western Pacific. Under the conditions of La Nina, where is the warmer water accumulated? Western Pacific. So, in the Western Pacific, you have accumulation of warmer water significantly and substantially so. Right? Be it a La Nina condition, be it the normal Walker circulation, you have accumulation of warmer waters. And these warmer waters are kept in place, in their own place, with the help of what? With the help of these trade winds. The trade winds, remember the bucket example, as long as the fan is switched on, the bucket will have water accumulated on its one end. But the moment you switch off the fan, all that water flows back. So these trade winds, they hold that accumulated warm water in that area. But then, due to weakening of the subtropical high pressure belt, remember these trade winds are getting supplied from subtropical high pressure belt. If I were to ask you another question, which other planetary wind is supplied from the subtropical high pressure belt? Let me see if we have any clue. I already told trade winds. Which other planetary wind is supplied from the subtropical high pressure belt? Good, Ravi. Akshay correct, Sakti correct, Meera correct, Gaurav correct. How many of you have not heard the question and have no clue what is going on? Okay. Fair enough. So most of you have given the correct answer. So the subtropical high pressure belt, which is a dynamically induced high pressure belt, means that high pressure at the region of the subtropics is not created due to low temperature. That high pressure is created due to sinking of air. So that subtropical high pressure belt is responsible for the generation of the trade winds as well as for the generation of the westerlies. They also get supplied from the subtropical highs. Now, when the subtropical highs, they get weakened. How will they get weakened? Because of extraordinary heating of the Pacific. If and when they get weakened, these wind supplies, they get impacted. The trade winds, not only do they become weaker, they can disappear as well. And these trade winds, when they disappear, what will you have? You will observe that all this warmer water which was present, this warmer water actually begins to flow back. Flow back depending upon what was the potential energy, how much accumulation was there. It will flow back, it will accumulate in this area. It will get removed from this location, and it will get accumulated in this area. That is the warm water which has actually flowed back. Now this warm water which has flowed back, now this is warmer obviously, so it will have a low pressure. So that means it will start attracting winds from all sides towards this region. Winds will get attracted to here, right? They would rise up. When they rise up, they would form convective clouds. Significant amount of rainfall would be caused. The Peruvian coastline receives rainfall. That is what the fishermen had found out as the condition of El Nino. This will move. Meanwhile, here, as the winds are blowing, in the western coastline of Australia, or western part of Pacific Ocean, the eastern part of Australia, you would experience that as the winds are blowing away, they would carry the surface water along with them. So the subsurface colder water will now get exposed in this region. The subsurface colder water will get exposed here. And that means there is a high pressure. Over a period of time, as more warm water or more surface water is carried by these winds, this low pressure will get much more intense. And what you achieve at the end of it is a circulation, which is the reverse of the Walker cell. And that is the condition of El Nino. Okay? Is that understood? Priya, is there any fixed phenomena of weakening of trade wind, any fixed pattern? No, it is observed upon the heating of the Pacific. For example, let me give you the example what is happening this year. So I hope you are aware that, or in case you are not aware, before this year, that is 2022, 2021, and 2020, it was a very rare occurrence, once in a century kind of an occurrence, where for 3 consecutive years the Pacific experienced the cooling phase. That is, you had La Nina conditions continuing for 3 years. Generally, these conditions they persist for 1 year, at max for 2 years, but not more than that. But in the Pacific, you had this happening for 3 years. That is what was also known as the triple dip La Nina, right? Triple dip La Nina, you would have heard in news stories multiple times. So that was a common thing, or that was something which was observed last year. Dip La Nina. Okay. Now, this was a very rare occurrence. But this also meant that you would have a lot of accumulated water and with a substantial amount of height in the Western Pacific. So easily the water could flow back. And as is the pattern for the last couple of years, the amount of heating has increased. Pacific has also gotten warmed up. I don't know if you are following the news headlines beyond your Tej and Arabian Sea. How many of you have followed the news that there is a hurricane which has made a landfall in Mexico today? Anybody who has followed that particular news? Or are we simply concerned about the fact that urgent high alert issued for Tej, a super cyclone? Okay, you have heard about it, right? So do open up your eyes and ears to what is happening across the globe, not what is fed to you by the Times of India and such masala news headlines. Do open up your eyes and ears to what is happening in Pacific, what is happening in Atlantic. Okay, so basically, no, this would not be covered in your. I don't think this would be covered in your DNA. I don't think so. This is something for which you have to be on your lookout. So basically, when we talk about the warming of the Pacific, so 2023 was the one when the Pacific waters were warmer. In general, you had the region of the Central Pacific experiencing a temperature which was around 1.4, 1.5 to even 2 degrees Celsius warmer than the normal conditions. So that is why tropical cyclones are also developing. And this is the reason why tropical cyclones are hitting the region of Mexico, and more tropical cyclones are expected to come in the way. So, what that means is when the Pacific is getting hotter, the subtropical highs will get weaker. And the subtropical highs, when they will get weaker, the trade winds will get weaker. And that means all the accumulated water for the past 3 years, that will tend to flow back. And it has flown back. This year it has flown back. But think about it that this year, when the water has flown back, 2023 is not a strong El Nino year. 2023 is a weaker El Nino year, in the sense that the pressure gradient across the Pacific has not built up sufficiently. This feature is expected, this phenomena is expected to peak later this year or the month of January, February, that is the southern summer, when that heating will be exaggerated, when that wind pattern will be established towards that low pressure. That means more upwelling across the region of Western Pacific. That means a clearly designated high pressure in the region of Western Pacific. So next year, 2024, is expected to be a strong El Nino year. Okay, so that is the how the pattern plays out. Maybe after next year, you will have the conditions reverting back where the trade winds will re-establish themselves, and they will carry all this warm water to the region of the Western Pacific, and you might have a neutral or a normal condition. Okay, now here, when we talk about this, basically, just a moment. Yeah. When we talk about the condition of El Nino, it is associated with higher than average, or let's talk only about India, less rains in India during the monsoons. But in general, if you have this low pressure across the region of Eastern Pacific, that means the Peruvian coastline this time will receive rainfall, whereas the Australian coastline this time will be dry. It is in these dry conditions, because the month of November, December is generally summer season in Australia. So when these dry conditions are accompanying that summer season, that is when Australia suffers from wildfires, forest fires, and bushfires that you generally observe. 2019 was when Australia significantly suffered from that wildfire. Okay, so these events are basically a kind of an extension of the impact of El Nino. So here, if you take a look at El Nino, so due to weakening of the trade winds, the accumulated water across the Western Pacific starts to flow back, leading to redistribution of warm and cold waters. Due to this, there is change in weather conditions, leading to drought-like conditions near Australian coast, while causing floods across the Peruvian coastline. So that is the event that we experience in the situation of El Nino, associated with less than average rainfall in India, especially during the monsoon season. Now, here you observe the global circulation initiated during El Nino. Observe the waters of the Pacific. Observe, during La Nina, you had colder waters which were spread over. This is when you have warmer waters which are spread over. So this is also El Nino, that is why is also referred to as the phase of warming of the Pacific. Because only when the Pacific Ocean warms up, the subtropical high pressure weakens, the trade wind weakens, and the water starts to flow back. Okay. And here, if you observe, you have the high pressure. Observe here in the region of Indian Ocean, that is the region of Western Equatorial Indian Ocean. There you have a rising air column, isn't it? That means you have a pre-existing low pressure belt or a low pressure zone. And that is a condition conducive for formation of a tropical cyclone. It is in these conditions when Arabian Sea starts breeding tropical cyclones, when Arabian Sea starts giving rise to more tropical cyclones. That is the reason why even this year you would experience that there is formation of a cyclonic disturbance happening in Arabian Sea as we speak. So out of the three phases of the ENSO or El Nino Southern Oscillation, only during the conditions of El Nino will it be conducive enough for Arabian Sea to experience tropical cyclones. Otherwise, in the rest or the remaining two conditions, it is conducive for Bay of Bengal to experience or to receive a cyclonic development. Okay. Now, here Observe the impact of El Nino, La Nina on the monsoon. So here, if you observe it, in 2004, we had El Nino, conditions of drought. So you had 88% of rains as expected. From average, we received only 88% of rainfall. Next year, in 2005, you had neutral conditions. Neutral conditions mean 100% of the expected rainfall. Then next year, again, the neutral conditions prevailed, 103% of the expected rainfall. 2007, La Nina conditions prevailed, so 110% flooding was experienced in many parts of the country. 2008, again, La Nina, 105%. But observe, La Nina was already getting weaker. By the time that you move from 2007 to 2008, La Nina was getting weaker. And that laid the groundwork for a very strong El Nino to hit in 2009. And that is when we experienced severe drought. And then 2010-11, again La Nina. So initially 100%, then as it persisted, 104%, mild El Nino, neutral. So like that, it impacts us almost year after year. So for the past 3 years, we had been experiencing the conditions of La Nina, above average rainfall. Last year, the La Nina was comparatively weaker. So we had above average, but not as high as 2021. And then basically, this year we have a weaker El Nino. Next year, we are going to experience a stronger El Nino. Now, earlier, these El Nino events would repeat themselves once every 7 years or 5 years, because in between you would have La Nina conditions sometimes neutral conditions. So El Nino would repeat itself every 5 to 7 years. But because of global warming, the sea surface temperature is rising incredibly. And as the sea surface temperature is rising up, that means the warming phase of the Pacific is becoming much more frequent. That means El Nino events are becoming very recurrent. Very quickly, they get repeated and they will get stronger as well. Okay? Hope this data will not be asked by UPSC. I will assure you that this data will never be asked by UPSC. This is just for your reference. Pranay, so this year El Nino can be one factor for the Tej cyclone. Yes, obviously, that is what I told you, that in the conditions of El Nino, you will have a kind of a weaker pressure created, or a kind of a lower pressure created in the region of the Western Indian Ocean, in the region of the Arabian Sea, Southwestern Arabian Sea. So that is a necessary condition. Remember, in the conditions of tropical cyclone, we had seen that a pre-existing low pressure is always beneficial for the emergence of a tropical cyclone. So here also, that pre-existing low pressure becomes one of the necessary factors. Okay. Now, we'll take a question from this area. Does that mean that 2024 India may experience drought conditions? Not exactly drought conditions, but the rainfall expected is supposed to be lesser than what we received this year. Already you would have seen that July we received rainfall, June we received rainfall, August was much drier, right? September also in many parts of the country was much drier. So that has already begun to indicate its influence. And next year it can get exaggerated, because as we speak, we are entering into the phase of the southern summers. This is when the El Nino conditions, La Nina conditions, they are at their peak. So this will peak and will have its further impact next year as well. Okay. Now, let us take a look at the question. Read the question carefully. La Nina is suspected to have caused recent floods in Australia. How is La Nina different from El Nino? La Nina is characterized by unusually cold ocean temperature. So read it up and I will give you 1 minute time. Let me know the answer. Read it up carefully. Gaurav, they get stronger in November and December because that is when it is southern oscillation, slightly to the south of equator. So that is when the heating of it is in southern summer much more exaggerated. That is why. Madhuri, incorrect. Priya, as you said, some news was not carried. Does it mean that we need to explore other news even after DNA? I would suggest to you get into the habit of reading newspapers. Always that is beneficial. Shahid, correct. Nikhil, yeah, true. Pranay, yes, once you understand these phenomena, understanding the features of what is developing in the weather pattern across us becomes easier. So good, while a major number of you have given the correct answer, but quite a substantial amount of you have given the incorrect answer as well. So let us read the statement carefully. La Nina is characterized by unusually cold ocean temperature in equatorial Indian Ocean, whereas El Nino is characterized by unusually warm ocean temperature in the equatorial Pacific Ocean. Is that statement correct? Have we talked about Indian Ocean at all in terms of its temperature till now? No. So La Nina is characterized by cold temperature in the Pacific Ocean. El Nino is characterized by warm temperature in Pacific Ocean. So this is incorrect. Second, El Nino has adverse effect on southwest monsoons of India, but La Nina has no effect on the monsoonal climate. We have seen with the data pointers also that La Nina leads to increased amount of rains. So this is also incorrect, right? So the correct answer in this case, neither one nor two. Okay, I hope that is understood, right? Any doubts that we have till now? No? Perfect. So, break. Okay. Okay, fair enough. Before starting the Indian Ocean dipole, take a break, refresh yourself, and then come back and we initiate the discussion for Indian Ocean dipole. Okay. So I think a break of 10 minutes would be sufficient. So let's take a break of 10 minutes. Let's be back and study about Indian Ocean dipole. A confirmation about the audio, please, guys, if the audio is clear and available. Thank you. So now we proceed ahead with the portion of Indian Ocean Dipole. Now, what we have seen till now in the case of the ENSO cycles or the El Nino Southern Oscillation movement, we have basically observed that across the two ends of the Pacific, you have different temperatures, etc., which are attained. Right. Now, that temperature attained across different ends of Pacific is attributable to the behavior of the trade winds. But when we talk about Indian Ocean is not as wide or as big as the Pacific Ocean, but still around the region of equator, it is still bigger as compared to the Atlantic Ocean. So in the Indian Ocean also, different ends of Indian Ocean, that is the western and the eastern end, they experience getting heated up at different rates. And this is purely because of solar insolation, because of wind factor, etc. So when you have the western part of Indian Ocean or the eastern part of Indian Ocean experiencing a higher or a lower temperature, so you have a circulation induced even in the Indian Ocean. And that different temperatures across two ends of the Indian Ocean, that is Indian Ocean dipole. So when we talk about the Indian Ocean dipole, it is also referred to as the El Nino of the Indian Ocean, in the sense that it also creates a condition like different pressure conditions on different parts of the Indian Ocean. And it is defined by the difference in temperature between the two areas, that is between the two areas or poles, hence a dipole of the Indian Ocean. A western pole near the Somalia coast and an eastern pole in the eastern Indian Ocean to the south of Indonesia. So the two ends of Indian Ocean, that is here and here, you have different amount of temperature which is experienced, a higher or a lower temperature that induces a pressure difference, and that can bring about a circulation here. Okay. Now, if you take a look at it, it is a sea surface warming phenomena with different regions of Indian Ocean heating up at a different rate due to the properties of the nearby landmass. And in many of the times, it is heating of Eastern Africa influences the Western Indian Ocean. And then heating of Indonesian islands influences the Eastern Indian Ocean. Okay. So sometimes heating of the nearby landmass can also influence the temperature that the sea surface indicates in that area. Okay. Prevailing wind patterns, the oceanic circulations, all of these are at play in inducing different conditions of temperature at the eastern and the western end of the Indian Ocean. And this induces a thermal pressure difference across the eastern and the western end, which in turn initiates atmospheric circulations, which can also influence the impact of ENSO cycles across the Indian Ocean. Okay, so that particular circulation which is induced can impact the ENSO cycles. Always recall that and always remember that in the Indian Ocean also, the circulation which can be induced, that can influence or play with the circulation which is already in place due to the ENSO cycle. So that means that ENSO, its impact can be counteracted or can be exaggerated by the Indian Ocean dipole. Okay. Now, here, let us understand the phases of Indian Ocean dipole. Phases of Indian Ocean dipole. So, like the ENSO, this also has got three different phases. So, you have obviously the neutral phase, you have the negative phase, and then you have the positive phase. Okay, and this keeps on moving between one to another, and it can change on a month. It is not like the ENSO that it will repeat itself after 4 years, 5 years. No, it can change itself from positive to neutral to negative on a monthly basis as well. On almost on a daily basis, the temperature is measured across the portion of the Indian Ocean, and that is in itself sufficient. That temperature measurement gives us an idea that, okay, if the eastern Indian Ocean temperature is, let's suppose, 27.5, on the western part if it is 27.6 or 27.7, that in itself is a temperature difference. Now here, when we talk about the neutral condition, what is the neutral condition, or what does the neutral condition here look like? It is not the neutral condition of ENSO. It is not the Walker cell. So what is the neutral condition of IOD appear to look like? So I want you to take a look at this particular image. This is that of Indian Ocean. And by the way, there's a difference between the eastern part of the Indian Ocean and the western portion of the Pacific. Many of the candidates I have seen, they think that eastern Indian Ocean and western Pacific is one and the same. No. In between, there are a lot of land masses, lot of islands, and thousands of kilometers of sea in between. So please don't get confused that eastern Indian Ocean and western Pacific is one and the same. They are different. Now, what you observe in the region of eastern Indian Ocean, in this area, you have, if you observe it carefully, you have lot of land masses in the form of small land islands and water which is trapped in between them. It is not a kind of an open ocean there. You have water which is generally trapped in between them, isn't it? So you have a lot of these islands, a lot of these land masses, and substantial amount of water which is trapped in between them. So the water and the temperature of water is also influenced. So here when you talk about it, let's suppose, think about it, you have various different islands. Okay. And then in between them, you have water, lot of water, which is trapped in between these islands. They don't have a free circulation, they don't have a free movement. Now, as these islands, these are your islands, these islands obviously will get heated up quite significantly because land gets heated up much faster as compared to water. Now, as these islands will get heated up, that heat will also be supplied to the nearby water body, isn't it? That heat will be given to the nearby water body. So what will happen to the temperature of the water which is trapped in between these islands and near these islands? The temperature will go higher. So that is why under normal conditions, under neutral conditions, the temperature in the eastern Indian Ocean is comparatively higher as compared to the temperature in the western Indian Ocean, right? So in the neutral condition or the normal condition, neutral phase of IOD, here temperature in the eastern Indian Ocean is higher as compared to the temperature in the Western Indian Ocean. Why? Because of the influence of the islands. Okay, so this is basically what you observe under normal or neutral conditions of IOD. Now, furthermore, if you take a look at it, now, if that region is comparatively warmer, let's suppose this region is comparatively warmer, the Eastern Indian Ocean is warmer. So that means there will be a low pressure. And if you have a low pressure, first of all, let us draw the equator. So here you will observe the occurrence of a low pressure under normal conditions. You have the occurrence of a low pressure, isn't it? And here comparatively, because it is warmer, the Eastern Indian Ocean is comparatively warmer, this low pressure will attract winds from the nearby regions, mostly from the west. So they will attract winds. Now these winds, when they are coming over, they will also end up causing significant amount of upwelling action. So here they will end up causing an upwelling. So when they will cause upwelling, here you will have colder waters, right? And that will bring about a comparative high pressure. So here also a circulation is induced. A circulation is induced here. And that circulation this time is happening in the Indian Ocean. Now, mind you, the circulation induced, as we have seen earlier also, the circulation induced by the IOD can counter the circulation by ENSO. So it can either exaggerate the impact of ENSO, El Nino and La Nina. It can nullify and counteract completely the impact of El Nino or La Nina as well. Okay, so that is where you have this as the normal phase. Normal phase or neutral phase of the IOD is associated with less than average rainfall in India. Okay, so keep that in mind. We will cover it in the next module in a greater detail, that when we talk about the neutral and the negative phase, they are associated with less than average rains in India. Okay, significantly less than average amount of rainfall which is received in India. And then positive phase is associated with surplus rainfall in India. In India. Okay. So we have seen what is a normal phase. Normal phase, Eastern Indian Ocean will be much more heated up. Why? Because the water which is trapped between the islands will not have that much circulation, and the islands will obviously, because land mass gets heated up at much quicker and a much more significant portion. So that is where the land mass, it gets heated up quite sufficiently. The water body in between that also gets heated up quite significantly well. So that is something that you observe here. Now, this neutral phase can intensify. This normal phase can actually intensify. So observe, this is your neutral phase. Neutral phase means you have a kind of a low pressure here, a kind of a high pressure here. Now remember, in the case of the ENSO cycles, we had talked about that how the neutral phase of ENSO can sometimes accelerate and intensify to a condition of La Nina. We had seen that. Something very similar can happen here also. When you have this low pressure created in the Eastern Indian Ocean, this will start attracting much more amount of winds. As more winds they start coming over, these winds, they will pull in all the surface water from the region of the Indian Ocean. Right? These winds, they will start taking in the surface water from the Indian Ocean. So in this area, the region of warm water, that will expand. So that means you will have much more intensified low pressure. Warmer water will be much more significantly more spread over. And in the negative phase, you have the cold water also due to upwelling, which will also be widespread. So just like how the Walker cell did intensify into La Nina, here also the neutral phase can intensify into the condition of the negative IOD. Now, in both these cases of negative and neutral IOD, if you observe, in the region of Western Central Indian Ocean, you have a high pressure. Here also you have a high pressure. So in both these conditions, the probability of occurrence of a tropical cyclone in the Arabian Sea region is very less. Whereas the probability of occurrence of a tropical cyclone in the Bay of Bengal is comparatively much higher in both these cases. However, in both these cases, we receive less rainfall in India in general, okay, as compared to the normal. Now, sometimes what happens is that you have significant heating observed in the region of the Arabian Peninsula, in the region of the Horn of Africa, right? The Rub al Khali Desert, which is present there, that gets heated to an extraordinary rate. And then the entire region, as it warms up, as it heats up, you will observe that it is the western part of the Indian Ocean which also gets heated up in the process. So that is the condition where, due to excessive heating of the region of Horn of Africa, the Arabian Peninsula in general, you will observe that the water bodies nearby, they also get heated up. So now this will be the region of low pressure. This will attract winds, causing upwelling in this area of Eastern Indian Ocean. Right? This phase of IOD is known as the positive phase of Indian Ocean dipole. This is going to support Indian monsoon, bring more rainfall in India in general. And remember, observe the pressure conditions in the region of Arabian Sea. It is conducive for a pre-existing low pressure. It is conducive for the occurrence of a tropical cyclone. That is why in the western portion or in the region of Arabian Sea, you have greater occurrence of tropical cyclones. Okay, so that is something. This is conducive for rains in India. Okay, now here we do know what is going to help rainfall in India, what is going to help formation of cyclones in Arabian Sea and Bay of Bengal. We have seen both in the case of ENSO and IOD. Always remember, if you observe the circulation here, the circulation pattern here, this can always either counteract or can add on to the phenomena of El Nino or La Nina. For example, El Nino is associated with less rainfall in India, positive IOD associated with high rainfall in India. If El Nino and positive IOD happen at the same time, chances are that the impact of El Nino is lessened significantly. And this was understood by us for the first time around 1997-98. Because around the time of 1997-98, the world experienced one of the most strongest El Nino of the 20th century. Basically, the Pacific had heated up quite significantly. Now, India was expecting a severe drought that year because stronger the El Nino, lesser is the amount of rainfall that India would receive. But surprisingly, India did receive lesser than average rainfall, but surprisingly, it was not a drought-like condition. It was almost closer to normal amount of rainfall that India received. Now that puzzled many of the climatologists. Later on, upon investigation, they found out that the impact of El Nino was cancelled to a greater extent by the existence of a positive IOD in the Indian Ocean, right? So they can counteract each other. Let's suppose there's a condition of what actually happened in 2007 when you had a condition of El Nino supported by a negative IOD. You experience a very strong drought because El Nino also means less rainfall, negative IOD also means less rainfall. So you had a significant drought. So they can support each other, they can cancel out each other's impact as well. Okay, let us take a look at the question which was asked from this particular area in 2017. For this question also, I will give you 1 minute. And here also, I expect you to read the question statements carefully. UPSC plays with the arrangement of the statements. Read the statement carefully. Okay, I'll give you 1 minute. I'm giving you more time. Read it carefully and come at the answer. Again, Indian Ocean Dipole is one of those topics that, as pointed out, yes, it is not going to be present in your NCRTs or any of your normal reference books that you come across. This is not something that you will find. Correct, Shayad. Madhuri, correct. This time, Madhuri, you have read the statement carefully. That means Usna, correct. Good. Very good. Substantial majority of you have given the correct answer. Satyanarayan, correct. So here, let us take a look at the statement once again. With reference to, now, let me also tell you how to approach this question in the sense that it can be possible that in the exam hall, especially in the prelims, the pattern of questions that prelims you are observing nowadays, you would be completely, in a way, it would be completely stupid on the part of the candidates to think about that prelims is going to be very conducive for them. And that means you are oblivious to the present reality. So prelims basically is becoming unpredictable in the sense that you have many topics which are asked. You would have heard about it somewhere, but you are not sure about what that is. So how do you deal with this? Let us understand. With reference to Indian Ocean dipoles sometimes mentioned in the news while forecasting Indian monsoon, which of the following statements is or are correct? Now, what can I derive from the question statement? Sometimes mentioned in the news while forecasting Indian monsoon. That means it has got a role to play in impacting Indian monsoon. And this is talking about Indian Ocean dipole. So that is something to do with the region of Indian Ocean. And it can impact Indian monsoon. These two conclusions we have. Now, IOD phenomena is characterized by a difference in sea surface temperature between tropical western Indian Ocean, till now it is correct, and tropical eastern Pacific Ocean. Where is tropical eastern Pacific Ocean? Peruvian coastline. We are dealing with Indian Ocean. Obviously, even if I don't know what Indian Ocean dipole is, I would be smart enough to understand that something in Indian Ocean would not have much to do with what is happening across Peruvian coastline. So this is going to be incorrect. Then an IOD phenomena can influence an El Nino's impact on the monsoon. So El Nino does impact monsoon. IOD will have an impact on monsoon. We have seen earlier. There is a probability of them having an interplay between them. So this is correct. See, understand. Here, this is the approach I want you to take for around 20 to 30 questions that UPSC is asking nowadays, where UPSC is expecting the candidates to solve those questions by pure logic. where you would have heard about the statement somewhere, you would have heard about the concept somewhere, maybe 5 years ago or somewhere, but you don't know the exact details of that. So how do you solve? Do you leave those questions? No. Out of those 25, 30 questions, your aim should be to get at least 15 or 16 of them correct. So how do you get that? You get that by getting at it or solving each and every statement, question of it, every word of it, analyze it. You will be able to solve it. Okay. General prelims pattern is basically, when you talk about the prelims pattern, 45 will be the basic questions. 30 to 35 are logical, logic based. 20 are factual. And as I have reiterated multiple times, the problem starts when the candidates start preparing on this. That is when you deviate from your path. That is when you start chasing facts, which UPSC asked in 2020, did not repeat in 2021. UPSC asked a separate set of facts in 2021, did not repeat in 2022. It did ask a separate set of facts in 2022, it did not repeat it in 2023. This year also it has asked certain facts, it is not going to repeat next year. So your preparation should be based on this 45 to 50 factual basic questions that you get. Out of those 45 to 50, ideally, you should ensure that you are able to attempt around 42, 43 of it with minimal number of mistakes. Mistakes will be there. So let's assume that there are 50 questions which are there from basics. Attempt at least 45 to 46. Ensure that you don't have negative for more than 5. Okay, more than 5 negative should not happen. Okay, now let us take a few questions. If there will be Western Pacific Ocean, yes, then also it is incorrect. Yes, Shayad. Is Atlantic Ocean also has these types of phases? See, actually, Shiva, a good and a pertinent question. But if you observe the geography of the region of Atlantic at equator, Atlantic Ocean at the region of equator is very narrow, much narrower as compared to the Indian Ocean, much narrower as compared to the Pacific Ocean. So while it does not develop a kind of a definite polarity like this, but there is a small feature or an occurrence there also across both ends of equatorial Atlantic, what is referred to as the Atlantic Nino. Right. So that is something which is also there, but it is temporary and nowhere as strong as the IOD or the Enzo cycle. But a good question. And Anuranjan, how is it possible that high pressure creates over northwest of Australia due to IOD, and low pressure over northeastern region of Australia due to Walker circulation? Why can't it be possible, my dear friend? North Australia is a continent, it is very, very large. Northwestern part of Australia, many of the times the maps, see, I hope you are aware that of the cartographic discrepancies, that the maps do not tell you the exact dimension of a region. So when you talk about the northwestern part of Australia, the pressure can significantly be different from the region of east, that is the Coral Sea, the region around Great Barrier Reef. The pressure there can be different. And please understand, in the condition of the Enzo or a Walker cell, the extent of it, the low pressure, extends all the way from Indonesia, Philippines, all the way till the region of northern and eastern Australia. Whereas the IOD is restricted itself to northern and only the western portion. Okay, and IOD is not a long phenomena like the Enzo. IOD is not going to persist in a similar pattern for the whole year. Chances are that if you have that Enzo cycle or the Walker circulation which is strong enough, chances are that IOD phenomena might even get influenced slightly by that. Okay. And Madhuri, how many questions solved in daily for geography? Just take a look at the areas that you have covered. From those areas, try to tackle as many different types of questions. You will get few of the factual ones also. Don't get perturbed by that. Understand those factual questions have been asked either because of current affairs that year, or just to put you out of your comfort zone. So you will get those. Don't worry about it, but try to tackle as many questions. So for that test series that we have, the prelims test series, etc., that we have, that will perfectly fit the bill. Kirti, these all phenomena are equatorial. Here it is written tropical oceans. Okay. So see, understand. One, I think another student had the question that you had mailed to me about that. When we say tropics or the tropical region, within that, a subdivision is the equatorial portion. Tropical region means from Tropic of Cancer to the Tropic of Capricorn. In that entire region, we talk about it as the tropics. The temperature is higher in the tropics, right? So equatorial area many of the times is used as a kind of a subdivision in that itself. But also you have to understand that it is not exactly only at equator where it is happening. In the case of Enzo, slightly below, slightly above equator also it is happening. Same is the case with IOD also. So larger and better connotation will always be tropical. Okay. Ganesh, obviously yes. No, IOD will not be able to influence El Nino and La Nina. It will be able to influence the impact of El Nino and La Nina. Okay. And is IOD also for 3 years? Shilpa, no. IOD, the phenomena can change on a monthly basis, on a fortnightly basis. The conditions, the requirements can change. And then Anuranjan, is it not possible that low pressure of IOD get impacted by? Sometimes it gets impacted, but not significantly so, because they are separated by large distance of sea between them. Okay, and then you have a question from Ravi. Is there something like decadal Enzo? It is not a decadal Enzo. It is specific decadal oscillation, if that is what you are asking for. So that talks about the phases of the heating and the cooling of the Pacific, where it has been found out that Pacific for almost around 10 years, 8 to 10 years, it does exhibit a kind of a pattern of a higher temperature or a comparatively lower temperature. So that is referred to as the heating phase of the Pacific, the cooling phase of the Pacific there also. But the difference is from the Enzo that this influences the entirety of the Pacific, where the temperature of the entirety of the Pacific increases. So when you have the warming phase of the PDO, the Pacific Decadal Oscillation, you have more occurrence and more frequent occurrence of El Nino events. When you have the cooling phase of PDO, you have more recurrent occurrences of La Nina events. Okay. And Niranjan, Enzo is a longitudinal variation, but the water southern coast of South Africa, Enzo is a longitudinal variation. Okay, yes, but the water in the southern coast of South Africa is hotter than Somali coast during La Nina. Okay, that is that water that you observe is also initiated, or that warming of the water is also initiated by the warm ocean current, what you refer to as the Agulhas current, right? So that also comes into play during that phase. And when you have the conditions of La Nina, there is a substantial amount of high pressure which is exerted in the region of southern portion of Indian Ocean. Now that also helps us basically receive higher than average rainfall in India, but aided by that warm Agulhas current, it leads to heating up of the water in the region of southern part of Africa. Okay, and wherever you have high pressure, that means for a prolonged duration, you have a condition of lack of rainfall. So that also brings about that heating. Positive IOD influence Australian climate? Yes, it will. In fact, one of the reliable sources, if you have to find out, one of the reliable sources for the coverage or the idea of the recent developments which are happening in this, Bureau of Meteorology for Australian government is one of the good sources, which will give you the idea about what is ENSO, what is this Madden-Julian oscillation, what is IOD. So Bureau of Meteorology for the Australian government, do visit their website. They have got some good interactive videos there also. Okay. Is there any connection of ENSO effect towards Arabian Sea with disasters happening in Afghanistan? Which disasters are we talking about here? Are we talking about the occurrence of earthquakes in Afghanistan? I surely hope not. Because the occurrence of earthquake, is it so? Oh my, no, no. See, why do earthquakes happen and why does ENSO happen? Just apply your logic there. Okay. So ENSO is very, very different from what is happening, or atmospheric phenomena sometimes can influence the movement of the rocks, can speed up the movement of rocks in certain cases. But obviously, what is happening in the region of the Pacific will never influence the movement of the Indian plate or the Arabian plate, which is leading to the earthquake in Afghanistan. So obviously not. And they are very, very different things. And how to correlate ENSO with Ferrel and Hadley cell? So ENSO circulation basically is in existence in between the Hadley cells. They will impact the Hadley cells. When you have ENSO circulation across the Pacific, the Hadley cell almost diminishes in terms of its flow pattern, flow characteristic. El Nino is what weakens and sometimes totally nullifies the movement of winds in the case, because Hadley cell does include the trade winds. So when you have these ENSO or El Nino conditions, Hadley cell will be impacted. If the Hadley cell is impacted, obviously the movement of westerlies will be impacted, and that can further exaggerate the rate of heating, because as long as the winds are blowing, they provide that cooling effect. But when the winds become absent, that exaggerates the rate of heating. Okay. Now we move on to the other important atmospheric phenomena. That is your Madden-Julian oscillation, MJO. Now, Madden-Julian oscillation basically was a kind of an accidental discovery, so to say. You had two of the scientists and climatologists with the same name, Madden and Julian. They basically were present in Singapore, and they wanted to study the impact or the amount of rains received in the tropical regions of the world, and if there is any pattern to it, especially in around the region of equator. Now, while they were carrying out their study, they came across one of the incidents or events which was quite unique, in the sense that they experienced that every 30 to 45 days the region would receive heavy amount of rainfall, and again after 30 to 45 days basically it goes out of the window. So they were sure about it, that there is a kind of a cycle which is hitting that region every 35 to 40 days or 30 to 45 days, bringing about rainfall and then followed by dry conditions. Again, bringing rainfall, again followed by dry conditions. And they found out that it is like a kind of a traveling pressure belt, right? The pressure system is traveling across the planet like a conveyor belt. I'm sure most of you would be aware, all of you would be aware what is a conveyor belt, something that you see in escalators, in the malls, in the airports, etc., where you have a belt which goes like this, where even for baggage claim, you basically put your luggage on that and it simply ends up moving. So something like that, right? So when we talk about basically the MJO, they found out it was kind of traveling pressure system, which would travel across the entirety of the equatorial part of the planet from west to east, significantly aided by the rotation of the planet as well, because the planet is also rotating very fast in the direction west to east. So as the planet is rotating at a very fast rate, so that provides the momentum for that traveling pressure belt, and it was named as Madden-Julian oscillation. Still, a lot is not known about this. but we do know enough about how this travels. So basically, if you were to believe the French have put out a detailed theory about it, which now the US government is also, or the US Meteorological Department is also adhering to it. So they have basically classified this Madden-Julian oscillation and its development, its genesis, also in various different phases, 8 different phases, not at all required for your general studies. What is required for your general studies is to understand what exactly this is. So this is a traveling system of high pressure and low pressure. Now, quite a few number of times I have repeated this term, traveling low pressure and high pressure, traveling pressure system. What is traveling? And how is it traveling? So let us take a look at that. So here, the MJO is an eastward moving disturbance of clouds, rainfall, winds, and pressure that traverses the planet in the tropics and returns to its initial starting point in 30 to 60 days on an average. Each cycle lasts approximately for that time. So here, if you think about it, basically, this is a kind of a pressure system which travels. So you have the region of low pressure, right? So the winds will come here. They will form very thick, dense convective clouds, bring copious amount of rainfall. They will diverge. They will sink here. So these are your areas of high pressure. These are the areas of high pressure. So what this is basically the entire this pressure or the condition of a low pressure surrounded by two high pressure. This entire system is moving from west to east. And to some extent, it is also aided by the Earth's gravitational pull, Earth's rather rotation on its axis in west to east direction. Because as the planet is also rotating in west to east, it provides the natural momentum, natural inertia for the wind movement also to happen from west to east, for the air movement, etc. Everything further moves from west to east. Okay, so this is something that you generally come across. So when you take a look at this MJO cycle, basically you will observe that here you have the low pressure, right? Here you will have the sinking air. This is your high pressure. Here also you have the sinking air. This is also your region of high pressure. And basically, this entire system is moving eastwards. So that is your MJO. Now, this will always end up influencing the regional climate. The regional climate in that area will get influenced. If you have the low pressure system in that area, that region will receive heavy rainfall. If you have a high pressure system in that area, means no or absolutely little rainfall. Now, I understand that you would have a general curiosity of why this is into existence. So, very briefly, I'll tell you. It all starts from the region of Africa. African region and the continent starts getting heated up. And that is where you have a creation of that low pressure, especially in the region of western portion of Indian Ocean and in the land masses of Africa. And that attracts the winds. And that is how eventually you have that low pressure and high pressure system which is built. And this entire system then starts traveling, aided by the by the rotational motion and also aided by the high pressure getting converted into a low pressure and vice versa. How does that happen? We'll take a look at it. But it has got 8 different phases, which is covered in those 60 days, 30 to 60 days. First phase or the first and the second phase is the time that the MGO takes to cover the region of the Indian Ocean. Then in the third, fourth, and fifth and sixth phases, by that time, it manages to cross the entirety of the Pacific Ocean. And then eventually, in the last two phases, it manages to complete the movement over the region of Atlantic and as well as the region of Africa. So here, let us take a look at what this MGO appears to look like. So this is what you observe here. This is the region of that low pressure. Observe how wider an area is covered here. And here, the air rises up. The air rises up in this area. It diverges. And eventually observe in this area, the air will sink. So in this area, you will have the creation of a high pressure. Okay. So you have a creation of a low pressure and a subsequent high pressure also gets created. Okay. So accordingly, MGO is said to possess two different phases: the enhanced rainfall phase or the low pressure phase, and the suppressed rainfall phase or the high pressure phase. So this is your low pressure region, low pressure, and this is the area of high pressure. Okay. So how does it move? How does it translate? So basically, here, let us observe in this case. So if you have a low pressure in this area, let's assume, that means winds will come here. They will rise up, right? They will be rising up. They will be forming different clouds. And they will be bringing substantial amount of rains. Here, they will then diverge. They will be sinking over in this area. Okay. They'll be sinking over in this area. So these regions are your high pressure areas. These regions are your high pressure regions. Now, understand how can it translate, how can it move. So apply your logic for a few moments here. Consider the region of the high pressure and consider the region of the low pressure also. Now the low pressure, over a period of time, it is receiving rainfall for, let's suppose, 2 days to 3 days. Your area also, when it receives continuous rainfall for 2 days, 3 days, 4 days, the temperature drops, isn't it? Generally, after receiving rainfall, there is a cooling effect. So the temperature drops. So here also, there will be cooling effect and the temperature will drop. Meanwhile, in the region of high pressure, what do you experience? You have the presence of sunlight, extraordinary heating by the sun, and no rainfall, absolutely lack of cloud cover. So what will happen to the temperature in this area? The temperature keeps on rising up, keeps on increasing further. So eventually, here it will become very, very hot within 4 to 5 days. And this area will become very, very cold within 4 to 5 days in comparison. So that means the region of this low pressure will eventually get converted into high pressure, and this region of high pressure can get converted into low pressure. So if this high pressure, let's suppose it heats up quite significantly, it becomes warmer. So this will get converted into a low pressure eventually. That means the winds will get attracted here. They will start rising up and you have the entire cycle which moves eastwards. So that is a process or a phenomena which is observed as this entire circulation takes an eastward movement and covers the entirety of the planet around the region of equator. Okay, it does manage to cover the entirety of the planet around the region of equator. So that is something which is referred to as or is known as the Madden-Julian oscillation. Wherever that low pressure phase will come, the convective phase, wherever it will lie, this convective phase as of here in this image is lying where? Over the region of the central Indian Ocean. So that will create a low pressure in that area. So in that region, it will bring about accelerated rainfall. This MJO also has an influence on Indian monsoon. When you have the convective phase of the of this MJO lying over the region of equator, slightly above equator in the central Indian Ocean, it brings heavy amount of rains along with it. So that is what is generally associated. Okay, we come to the portion which is important both for your prelims as well as for your mains exam, and that is jet streams. Now, jet streams, what are these? By the way, for these, have you guys taken a look at the uh, animation videos which we have provided on YouTube for the portion of jet streams, latitudes, longitudes, etc., international date line? Any of you, have you managed to take a look at that? Yes? Good. So basically, for those of you who are who have not seen that, do take a look. It will further enhance your level of understanding. That is also present in the tablet lectures also, by the way. So tablet lectures, I'm sure many of you are not in the habit of watching it. It is something which has been there and it is kept. But do watch it. In many of the topics, in many of the chapters, we have included those animations for geomorphology also, majorly for geomorphology and some portions of climatology. It should help your level of understanding. What about the 8 phases of MJO? That is not required for you to understand. Or for general studies, no, for general studies, all you need to know what is MJO. It is a traveling pressure system. In how much time does it travel? 30 to 60 days. Where is it in existence? In the tropics, particularly around the region of equator. Now, does it have different phases? It has 2 phases, convective phase and the suppressed rainfall phase. And it moves eastwards, west to east, aided by the rotation of the planet Earth, and also aided how the low pressure gets converted into high pressure and vice versa. That is it. But if you further want to be just observe or want to know, so understand the first phase of MJO in terms of its development or in terms of its journey happens over Africa. It moves eastwards, takes 2 more phases to cover the region of the Indian Ocean, then takes 3 more phases to cover the entire length of the Pacific, and then eventually Atlantic and Africa. But again, that varies. And as we speak, there is a research which is being undertaken. Yesterday also I had mentioned about it. There's a research which is being carried out by members of IMD and also by members of the US Met Department in order to understand whether there is actually any relation between the MJO and ENSO cycles, whether they do influence each other or not. So maybe 4 years down the line, we'll know better. But as of now, this is what we know. Okay. MJO means each 4 days of rainfall and dryness happens. Yes. 4 to 5 days and then dryness. Can we write in which phase it moves in a specific? No, not required. UPSC is not going to ask you a mains question from MJO because not many people will have the content about it. Let me assure you, even this much detail that we have read about MJO, barely you will find a handful of candidates out there who will have this much about of detail. It is not covered in any of the books. Even for the optional areas, they don't cover MJO. In current affairs, it is mentioned sometimes because it can influence the Indian monsoon. That is why. But that is the extent of it. That's it. Okay, so I want you to prepare for it from your prelims perspective. And I want you to prepare for it in case there is a question about the impact of the atmospheric phenomena on Indian monsoon. You can also bring that as an additional brownie point, which will fetch you more marks. Okay. Now, jet streams. Yes. So we come to what we refer to as the jet streams. Now, the jet streams for the first time basically was again discovered accidentally by a French climatologist. A French climatologist in the 1920s. Basically, he was having a balloon experiment where you put certain parameters and certain instruments into a balloon, and then you launch it up in order to measure the wind speed at various different heights. Now, there itself, he basically had a conclusion that there is an existence of a strong wind movement in the upper levels of troposphere. But then after that, not much research was done in that area. Then further accidental discovery was done during the Second World War. During the Second World War, when United States was at war with the region of Japan, basically, the US bombers, they, in many of the bombing missions, they flew all the way to Japan, launched their bombs, launched their attacks, and came back all the way to US again. Now, the pilots, they observed something unique which they reported back. They observed that as they were moving from US to Japan, which was a kind of an east to west movement, right? They would experience a reduction in the speed of their aircrafts. And as they would be flying back, that is from Japan to US, that is from west to east, they would experience a sudden increase in the speed of their aircraft. Now, this was very unique. This was reported. And this helped the US bombing missions in many of the regions, because I don't know how many of you are aware of it. During the Second World War, one of the major challenges that US had was it did not have enough large bombers which could fly all the way around the Pacific. And this very fact that they could come back with a greater speed allowed them for fuel management in a better way. Now, the air headquarters were reported about this issue. In any country, the air headquarters basically does include the climatologist as well, because and the weather pattern is studied in greater detail. Now, the air headquarters observed this, but they observed almost something similar in the missions which were being carried out in Europe as well. That the planes which were moving from west to east at that height, they experienced sudden push in speed. And the planes which were moving from east to west, they experienced a reduction in speed. So what that meant basically was that there was in existence a very strong wind moving in the region of upper troposphere, and that was named as jet streams. Over a period of time, with the help of satellite data, etc., we have managed to increase our understanding of jet streams to a substantial extent, to a great significant extent. But still, a lot of it is left unexplored. So here, we shall be covering about what these jet streams are, where do they exist, and what are their properties. So in simplest of the terms, jet streams are representing, or they represent very strong bands rather, of fast moving air parcels, where the air parcel can move at a speed of close to around 300 to 400 kilometer per hour. And they move in certain set bands. It is not a kind of a uniform air movement happening across a wide spectrum. That happens in a set band, in a small area. And this moves in general from west to east in certain areas of the planet. So let us study more about it. So they are relatively narrow bands of strong winds in the upper levels of the atmosphere. By atmosphere here we refer to the region of troposphere. The winds blow from west to east in jet streams, but the flow often shifts from north to south, in the sense that when you talk about the planet, the jet streams, they move in a direction of west to east. But this movement can shift northwards as well. This movement can shift slightly southward as well. Okay, so here itself, you can experience a northward and a southward deviation. Now they travel sometimes in the tropopause, many times in the troposphere itself. The area between the troposphere and the stratosphere at heights of about 8 to 15 kilometers. So their height is not fixed. So if you think about this as the ground surface, let's suppose the jet stream is flowing here. Jet stream will have a variation in terms of its height. In certain areas, it can have a height of 6 kilometers. In certain areas, it can also go across to a height of 15 kilometers. Right. So there's a kind of a vertical variation in terms of its height. Now, when you talk about the shape and size of it, this is what the jet streams appear to look like. Observe the narrow bands of air which are moving in the region of upper troposphere. Now, the movement of it resembles like that of a river of air flowing. Now, in a river, what do you observe? When you think about a river or a river movement, always the speed of flow is going to be maximum in the central portion, isn't it? That is where the speed of flow is always going to be maximum. So here also you observe something similar, that in the central portion here, the speed, can reach a height, or the airspeed can be around 300, 350, 400 kilometers even. Right? So it is very fast moving air. So the strong air currents, which tend to look like wavy striated rivers, striated means you have a curvilinear path, when seen on a jet stream map, form when cold air and warm air meet. So now let us talk about the formation of these jet streams. So jet streams get created wherever in the upper atmosphere you have the meeting of the cold and the warm air. Right? So where is it that we experience that? As per the tricellular model of atmospheric circulation, here, jet streams, when we talk about the formation, so they get created whenever you have a very strong pressure difference in upper atmosphere. And why will that strong pressure difference be created? Because of the difference in temperature between the cold and warm air. So here I want you to recall the tricellular model of circulation, where we talked about the different zones. ITCZ, 30 degrees, 60 degrees, 90 degrees. So the tricellular model that we observed was something like this. Now I want you to tell me that in which of these areas will you experience a difference in temperature in the upper atmosphere, in the upper regions of troposphere? In which of these areas? So if I ask you here, in this area that is above ITCZ, will you experience temperature difference in this region in the air, in the upper atmosphere? What do you think? No? Why? Why won't we experience a temperature difference in upper atmosphere here? Yes. Why? Here, basically, you have the convergence of air happening from the tropics, right? From both the tropics, it is the air which is coming in from the tropical region. And the tropical region, basically, from where the air is coming in, tropics will have roughly the similar temperature. So from here, 30° north, 30° south, the tropical air will have almost a similar temperature. So as the tropical air will have a similar temperature, basically here also they will represent a similar temperature. Here also you will not experience any difference in temperature, because both the air parcels in this case, they are coming straight away from the tropics. Now, what about this area? Will you experience a difference in temperature in that area? Yes, you will. Why? Because observe, one of the air parcels is coming from the region of equator, one of the air parcels is coming from the region of 60 degrees. So obviously there will be a difference in temperature. So here you will have a jet stream. What about here? Will you have a difference in temperature in this region? Beautiful. Yes. Why? One of the air parcel is coming from the poles, other is coming from tropics. So again, a difference in air temperature. So that is where you have the jet streams which are generated. This is the polar jet. This is your subtropical jet. But here, I understand not a part of your syllabus. I understand in many of the areas I have transgressed into the regions beyond the general studies. But what I feel is sometimes you need to get to the depth of it in order to understand what is there even for your GS. So let us try to understand why these jet streams get created. Fair enough, in the books, everywhere it is written that difference in temperature in upper region will lead to the creation of jet streams. But why? How is it that difference in temperature at that region can create such a strong movement of wind? So, before we talk about it, first things first, we do know winds will blow from a high pressure to a low pressure always. Stronger the pressure difference, stronger will be the wind velocity. We know that fact. We also know that if the wind velocity is very high, Coriolis force is high or low in that case? If the wind velocity is very high, what about the Coriolis force? Will it be high or low? Beautiful. It will be very high. So bending will also be very high. With that basic concept, let us try to understand something. Let's assume this is the ground surface. Now let's draw columns of air. So first of all, warm air column. Warm air column will always have a higher volume, always, isn't it? Higher energy level, higher amount of volume. Let's assume a cold air column. Now, here, first of all, at the region of A and B, which will have high pressure, A or B? This is obviously cold air. This is your warm air. Which will have high pressure, A or B? Good. Almost a no-brainer. It will be B, having a higher pressure on the ground. Now, so basically, on the ground surface, the wind movement will be from B to A, always. This is something that we have read significantly in greater detail. But let us move ahead from here. Let us try to find the pressure here. At this particular height, if I name this as 1 and 2, what is the condition of pressure? Where is it that you think there will be high pressure? At the region of 1 or at the region of 2? Where do you think there will be high pressure? Good. Very good. So, it is at the region of 1 where you will experience a higher pressure. Why? Because above 1, you have a large column of warm air, but above 2, almost the cold air is almost negligible. I know that the cold air, and we all know that the cold air is denser. We all know that it has got a higher density of air molecules, but it is very, very thinly present at that area. Whereas in the region of 1, warm air is significantly existent and extensive as well. So that means in the upper atmosphere, we will experience high pressure here and low pressure here. Comfortable up till this point? Or do we have any doubts? Are we comfortable here? Good. So winds will always blow from a high to a low. So wherever you have warm winds, from there, warm air, from there you will experience a wind movement from here to here. But there will be deviation in the northern hemisphere towards the right, in the southern hemisphere towards the left. Now, let us implement this or project this on planet Earth. Or let's use this. So here, if assume that this is the region of equator, let's assume this is the region of equator. Now, you have in this area, the subtropical high pressure belt, in this region, you have a temperature difference, right? We have seen. Now, where is it in upper atmosphere? We're not talking about the ground surface. We are talking about this in the upper atmosphere, upper troposphere. So that you don't get confused if you decide to revise it someday. Maybe when the astrologers will find you a date that this is the perfect date to revise, whenever you do that, so that you don't get confused. So you have cold air from which area? In this region, can I say that cold air is present? In this and in the region of the tropics, can I say you have warm air which is present? Isn't it? Warm air which is present here also. Warm air is present here, upper atmosphere. Warm air, because this is the air coming from the ITCZ, which is warmed up. Here, warm air, and all those areas, we can say you have cold air, right? That means we have seen in upper air that the air movement is from warm to cold, and it will get deviated in what direction? In the rightward direction. So what will be the movement of the wind? West to east. But what about the polar jet in the region of the poles? There also a same principle will apply. In comparison, so let's suppose we talk about the polar region. Now in the polar area, you will have the region around 60 degree, 50 degree, comparatively warmer as compared to the polar winds coming always. So that means the polar region will be much more colder. Here you will have much more colder. In comparison to that, only in comparison to that, here you will have a bit warmer air. In the upper atmosphere, winds will blow from the region of warm air to the region of cold air because of difference in pressure. So, but they will deviate to the right. What is the direction that they take? West to east. So that is why these are the areas where the jet streams exist. And that is how the jet streams get created. And that is the direction that the jet streams take. Are we comfortable up till here? Or is there any doubt? Just one. You have a doubt. Okay. If cold air has high column, will it have a higher pressure? Just one, please understand. Cold air can never have a higher column. For example, if you consider it in this case, in the image given, above it, it is very less. But let's, in a way, entertain the thought that you have put forward. So let's assume we consider the region here at this height. So here the cold air has got substantive amount of column above it. So here cold air region will be the region of high pressure. But as we start moving in the upper altitude, in the region of upper troposphere, by the time we come to the aforesaid or the aforementioned region this way, here you would observe that the cold air is almost negligible. That is why oftentimes the wind direction in the lower atmosphere or the surface is oftentimes very different from the wind motion and the wind direction in the upper region. Okay? Is that understood, just one? Okay. Now, Ganesh, deviation in the direction is because of the Coriolis force. The Coriolis force bending. In the northern hemisphere, the Coriolis force will bend the wind to the right, and in the southern hemisphere, Coriolis force will bend the wind to the left. Okay. Now, for all those who are basically looking at it only from the perspective whether this is important for the exams or not, UPSC has asked a question earlier as well about the formation of the jet stream. And it is only by these kind of explanations and diagrammatic representations that you can always gain an edge over your competition. Again, let me tell you, in all the GS books that you go through, you will not find this available. So please do revise it. Please do write it down somewhere. And when the time comes in the mains exam, do depict this. And trust me, minimum you will get 4 to 5 marks addition from what your competition is securing. After all, that is the aim eventually. I hope so. So do take this advantage. Don't let it go to waste. Okay. Shiva, can we say that jet streams are due to difference in air column in the upper atmosphere? Yes, why not? And you can definitely use this explanation with the image representation in the exam. Always use this image representation. Okay. Now, this is the reason why you will observe that the jet streams that are not straight. Jet streams are oftentimes wavy in nature. If you will observe the movement of the jet streams, here also if you observe the movement of the jet streams, they are wavy. Why is it the case? That is because the extent of warm air and cold air, as we have seen yesterday also during frontal formation and during the creation of the air or the existence of the air masses, that difference between or the boundaries of the warm air and cold air, they don't form across a straight line. They will form a kind of a deviated set of pattern overall. So that is something which is also experienced in the case of jet streams. They will have a kind of a bendy path. They will have a kind of a wavy pathway. Okay, because in certain areas the region of warm air extends for further. In certain areas the region of cold air extends furthermore. Greater the difference in temperature in the upper atmosphere, stronger will be the jet stream movement. And that is a normal logical explanation in the sense that greater the difference in temperature, obviously, the pressure gradient will also be higher in the upper atmosphere. So the jet streams will also be stronger. So that means jet streams are stronger in which season? Summer or winter? What do you think? Very good. Jet streams will always be the strongest during the winter months because that is when the difference in temperature between the tropics and the polar areas are significantly exaggerated. That is when it will be very, very strong. Okay. Now, in these jet streams, as we had seen earlier, there is a kind of a vertical movement or the vertical variation as well. Now, in certain areas, you will find the height significantly higher. In certain areas, the height is very less. Why is that? Because the height of the cold and the warm air mass, they are not always consistent. Cold air is having a shorter height, warm air is having a greater height. So that is where in the jet streams also and everywhere, depending upon the terrain also, this will vary. So that is why jet streams observe two types of wave. One wave is the horizontal, is a kind of a vertical up and down. Other is a horizontal wave. So in three-dimensional figure, if you have to imagine, think about it, that it goes up, comes down, again goes up. So it is a kind of a three-dimensional wave motion. Okay. Now these jet streams, they are categorized based upon the, just like in the wind systems, we have the permanent wind system and the local wind system. Permanent wind systems are existent throughout the year, existent across the planet, and local wind systems are temporary in nature. Here also, when we talk about the jet streams, we have the permanent jets, and temporary jets. Permanent jets, they are created around the region of these pressure belts that we have across the boundary between the Ferrel cell and the Hadley cell, and Ferrel cell and the polar cell. So you have, in total, how many permanent jets do we have? Apply your logic. Across both the hemispheres combined, in total, how many permanent jets will you have? Good. 4. So you have 4 of them, 2 in each hemisphere. That is polar jet. Polar jets are comparatively always going to be much stronger as compared to the subtropical jet. Subtropical jets, also referred to as subtropical westerly jet stream, because the jet stream in general, the permanent jets, they will move from west to east. We have seen why the movement is from west to east. Temporary jets, they are in existence in certain small parts of the planet, and that too for a temporary duration. So when we talk about temporary jets here, we have the case of, for example, Siberian jet, Somali jet, tropical easterly jet. This is something that we are going to study again in the next module, because this influences Indian monsoon. Easterly jet. These are your temporary jets, which are in existence only in small parts, and that too for a very temporary duration. So this is about the factors of jet stream. So they are stronger in winter in the northern and the southern hemisphere. Why? Because that's when air temperature differences that drive them tend to be more pronounced. Actual appearance of jet streams result from the complex interaction of many variables such as location of high and low pressure systems, warm and cold air, as well as season change. They meander across the globe, dipping and rising in altitude at times, forming eddies at times. Eddies are what? Where you will observe from satellite map, if I can show you. Observe this carefully for a brief moment. This is a kind of a representation of a jet stream as per the basic manifestation of the satellite data, crunching of the data pointers. You observe here that this is how the jet stream is in existence. This is how the jet stream is in flow. Observe how it splits here, right? Observe how from here one band of air comes over. It forms a kind of a circulation, right? Here also, so that variation that you observe is aided by the small localized low pressure, high pressure, etc., which is built, the influence on the pressure systems that influences the jet stream movement sometimes. But that is not something which is a fixed pattern, that this is where it will develop certain circulation eddies or circulation pattern. It tends to vary. Many of the times, these jet streams are impacted by the physical barrier as well, right? For example, the region of the Himalayas, if I can show you the satellite map, the region of this is the subtropical westerly jet. Now observe, this subtropical westerly jet is completely absent here. Why? Because they have encountered the Himalayas. So Himalayas are in existence in this region, isn't it? This is the area which is the plains and then the plateau area. But observe that the impact that these mountain systems in this area including the Hindu Kush, everything, the impact that they will have on the jets, it gets divided into a northern branch and a southern branch. Right? So even the physical barriers can end up dividing these jet streams. Okay? Its influence on weather conditions and weather pattern is something that we will cover after the break. Okay, so let's take a lunch break and we'll be back by 2:15 is when we'll be back, and we will continue once again from here. And that is when we will be covering the portion of Indian monsoon. Shiva, variation in height of air column causes vertical wavy pattern, and variation in extension of air masses causes horizontal wavy. And we will be back in 1 hour. It's your lunch break. So 2:15 is when we'll be back, and we will continue with the portion of the impact of jet streams on the weather pattern and then Indian monsoon. Okay.